Hello and welcome back to the course on blockchain. And today we're going to have a demo of how private keys, public keys, and signatures work. The demo is located on SuperData Science, so if you'd like to follow along, the URL is tools.superdatascience.com/blockchain/public-private-keys/keys. I know it's a long URL to type, but if you go to the course notes, you'll see the URL there and you can just click on it. And before we get started, a huge thank you to the person that created this. It was created by Anders Bronwerf. As you can see, the copyright notice is here, and a huge thank you for allowing everybody to use it freely. So if you'd like a copy of your own, you can go to GitHub and you can copy it to your website and play around with it too. All right, and also a huge thank you to the team of developers at SuperData Science for putting it up here. Okay, so let's have a look. In the first one, as you can see, there's a couple of menus here, so we'll go through a few of them. So in the first one, we've got an opportunity to see how, let me bring up the slides, that'll be handy. So we have an opportunity to see how this link works between the private and the public key. So there's our private key, there's our public key. So if we generate a random private key, we will get a public key. And as you can see, it's always a fixed length. It's always a hexadecimal number, whereas a private key is just a normal number. So you can actually type in your own private key. So whatever length private key you type in, you will get a fixed hexadecimal number. The interesting thing to note, or probably the thing to keep in mind, is that you don't want to short public key like 12, because anybody can guess that. That's why it's better to generate one randomly, or when you're creating a wallet, just accept the one that they give you. Well, I don't think you have much choice. They just give you one, and it's generated randomly like that. As you can see, it's a huge number, and so that's why it's considered to be unique to you. So that's our private key and public key. Now we're going to look at signatures. So as you recall, here what happens is we have the private key, and we generate the public key. We keep this to ourselves. This is available to everybody. Then when we write a message or create a transaction, we sign it with a private key, but everybody else can use the public key we have to verify that transaction. So here we've got a private key. You can type in here anything again as you like, and this is what we see in the sign phase, and this is what people see. For now, they can only see the public key. Now if we create a message, let's say Adlan sends to Kirill 0.2 BTC. So then what happens is, lost my mouse again, there it is. What happens is now I need to click the sign button, and this signature is generated from the message or the transaction that we've put in here and the private key. And so whenever the message is going to go anywhere, it's always going to have the signature attached to it and the public key, not the private key. So when we look here, you can see that everybody else in the network, all the nodes, will get the message or the transaction, the public key, and the signature, as we discussed here. Message, signature, public key, the ones that are highlighted in the yellow little highlight there. And so now they can use these three to verify if indeed this message, what are they verifying? They're verifying, very important, they're verifying that the signature belongs to the holder of the private key behind this public key. So that's what they're saying. So if they click verify and goes green, this could only happen in the case that indeed this signature was created by the person who has the private key to this public key. And obviously the signature is directly linked to this message. So if anybody tries to change anything and they verify, it doesn't verify. Or if they try to select this verifies, they try to change, or let's say they don't know yeah, so basically that's it. Like even if you change this, I don't know why you would change this, but like it doesn't verify as well. So, or signature, right? So if they don't have access to my private key and they try to forge a fake signature, so they put in, oh, well, there's no W's in a hexadecimal number. So they put in a fake signature, it's not going to verify. So only if you have access to the private key and you have the message when you have the private key, you sign it, you can see there, so 3044022, 3044022, and that's our public key linked to this private key. Then it will verify. All right, so that's that part. What do we have next? We've got a transaction. Okay, so here we're just replacing the message with a transaction. See, it says message here, but it's actually a transaction. And so again, you can put in any value. Let's say I want to send somebody 200. Well, here it says dollars. So from this address to this address, and it has a private key. So now we have more kind of details in the message itself, but the whole concept is the same. So here's my private key. Let's say we can put in, our own private key, if you like, just to test it out. You verify. There's the message signature. Now let's see what the public key for this would be, just to because in the verify we already have a signature here. Oh well, yeah, we don't have a public key seen, but in reality, what should be also shown here is the public key, because you cannot verify something without the public key. So if we go to keys and we put in our key here, you can see it's already put in for us. That's handy. So the public key, I just generated a random one. So the public key would be this one. And so people actually also see the public key because they need the private key, the public key, and the message, the contents of the transaction to, not the private key. What am I saying? They need, let's sign this again. So people need the message, the signature, and the public key, as we discussed here, message, signature, public key, in order to verify. And so as you can see, it verifies. And again, if you try to tamper with anything, it won't verify. I wanted to point out here for full disclosure, right now, I think this one works. If I try to tamper with this one, you see it works. But if I try to change this one, it still verifies, and that's our bad. We'll fix that. It's part of the code. We'll fix the code, so it actually shouldn't verify. So hopefully when you're checking this out, it will go red if you try to tamper with it. And also, but the signature works. So if I try to change anything, signature doesn't work. So you try to change anything in here, and in addition, let's remember you should also see the public key here. You try to change anything, it will not verify. Okay, so that's those. There's also this blockchain one. If you'd like to have a play around in your own time and see how it works in a blockchain, you're welcome to do so. Okay, so I hope you enjoyed today's tutorial. That's how private, public keys and signatures work. And I'll see you back here on the next one. Until then, enjoy blockchains.